हेलो विद्यार्थियों, मैं प्रोफेसर माखन सिंह चौहान इस संस्थान के गणित विभाग में प्रोफेसर हूँ। संस्थान के विद्यार्थियों के चहुमुखी विकास के लिए संस्थान में चलाए जा रहे विभिन्न फ्लैगशिप प्रोग्रामों में से ज्ञान मेघ प्रोग्राम के अंतर्गत इस वीडियो को आपके लिए रिकॉर्ड किया जा रहा है। इसमें आपका हार्दिक स्वागत है। यह वीडियो लेक्चर बीएससी सेकेंड सेमेस्टर मैथमेटिक्स के मेजर के विद्यार्थियों के पाठ्यक्रम को ध्यान में रखकर बनाया गया है। बीएससी सेकेंड सेमेस्टर के मेजर पाठ्यक्रम में कैलकुलस एवं डिफरेंशियल इक्वेशंस में कर्व ट्रेसिंग सब्जेक्ट से पर यह वीडियो बनाया जा रहा है। आज इसमें हम जो टॉपिक कवर करेंगे उनमें पहला लर्निंग आउटकम्स, लिंक टू प्रीवियस टॉपिक्स, इंट्रोडक्शन, historical background of curve tracing, basic concept and definitions, procedure of curve tracing, example of curve tracing, summary, link for further readings, references, and finally assessment. Now let us discuss learning outcomes. After studying this lesson, you will be able to remember the definition of curve tracing, node, cusp, point of inflection and point of askew inflection. You will able to understand the concept of symmetry and asymptotes. You will able to learn the procedure of tracing of Cartesian curves. Applying the procedure of tracing to trace the curve for further studies. And you will able to identify the curve in geometrical form. Link to previous topics. कैलकुलस से लिंक जो हमारा है, द कॉन्सेप्ट ऑफ कर्व ट्रेसिंग प्लेज ए की रोल इन कैलकुलस. इट हेल्प टू गिव द अप्रोक्सीमेट शेप ऑफ कर्व्स. ज्योमेट्री से जो लिंक है वो शेप्स ऑफ कर्व हैव एप्लीकेशन इन वेरियस एरियाज लाइक ज्योमेट्री, कंप्यूटर ग्राफिक्स and computational geometry, which can be found by tracing. Optimization of approximate shape of mathematical constants help to optimize the solution of given problem. And economics, approximate shape of economic conditions help to solve the given problem. Finance से इसी तरह से हमारा लिंक है. Financial problem can be treated in better way by converting it into mathematical form and then in geometrical form. Now let us introduce the topic. Historically, René Descartes initiated the idea to algebraic equation from the given curve. This gave the way to handle geometric problems through algebra. Pierre de Fermat did work in another direction and used equations to define new curves. Later on, Jacobi Bernoulli and Isaac Newton used the concept to another kind of coordinate systems. There are three types of curve. Cartesian curve, which are in y equal to fx, parametric curve, x equal to ft and y equal to ft, where t is the parameter, and polar curve, where equations are in r and theta. In this lecture, we will learn the procedure to trace the Cartesian curve. Now let us define some curve like curve tracing. Curve tracing is a technique for producing a shape of a given curve on the basis of its characteristics. Multiple point. if more than one branch of the curve passes through a point, then the point is called multiple point. Note, if the tangent are real and distinct at the point, then the double point is called node. Just like in the figure, this is the node. Cusp. A cusp is a point at which two branches of a curve meet such that the tangent at each branch coincide. Like this. This is the curve where tangent coincide of the curve. Now let us isolated point. If the tangent are imaginary, then the double point is called isolated point. Just like in the figure, this is the isolated point. A straight line which touches the curve at infinity is called asymptote. This is the definition of the asymptote. Like this curve, this is the asymptote. This curve will touch this line at infinity point. Now, procedure of curve tracing of Cartesian curve. Let us discuss. At first, we take the first point symmetry. So, we check the symmetry about x-axis. How we check? If powers of y are in even, then the curve is symmetric about x-axis. Now, symmetry about y-axis. How can we check? If powers of y are even. Seeing the like this, this is the curve symmetric to y-axis. Third symmetry check about the line y equal to x. Mutual exchange of x and y remain no change in the equation. Then the curve is symmetric about y equal to x, like this. This is the line y equal to x, and this is curve which is symmetric about the line the y equal to x. Now, third check of the symmetry, fourth check of the symmetry about the line y equal to minus x. If replacement of x by minus y and y by minus x make no change in the equation, then curve is symmetric about the line y equal to minus x. This is the line y equal to minus x, and curve like this, then this is the symmetric about line y equal to x. About origin, this is the fifth check of the symmetry. Replacement of x y minus x and y y minus y make no change in the equation, then the curve is called the symmetric about origin. This is the curve symmetric about origin. Now, let us check the nature at the origin. This is the second step of tracing. If the given equation satisfy 0 0, then it passes through the origin, otherwise not. Next check at the origin. Find the tangent at origin by equating the lowest degree term to the 0. So, tangent are important. Third work to check the nature of the curve at origin is the investigate the nature of curve at origin on the basis of tangent. If tangent coincide, then there is cusp, as we have discussed earlier. If the tangent are different, then the curve has node at origin. Now, third step of tracing is point of intersection of curve with axis. Intersection with x-axis, put y equal to 0 in the given curve, we get the point. Intersection with y-axis, put x equal to 0 in the curve, we get the point of intersection. If the intersection of curve is not origin, then shift origin at that point and check the nature of the curve. Shifting, how can we shift the origin? If point of intersection is another point, then the origin, say AB, then to know the nature of the curve at this point, we shift the origin temporarily on this point by replacing x by x plus a and y by y plus b. So, this is the fourth point, asymptote. Let us check the asymptote. We check parallel to the x-axis asymptote, equate the coefficient of highest degree term to 0. We get the asymptote parallel to x-axis. Now, another type of the asymptote parallel to y-axis, equate the coefficient of the highest degree term of y to 0. We get the asymptote parallel to y-axis. Now, fifth point of checking of the curve tracing, region of existence and non-existence of the curve. Solve the equation for as y equal to fx or x equal to y, which is convenient. And next, existence of the curve, we get check the value of the independent variable of x and y for which dependent has real value. If values are real, then curve exists. Otherwise, if values are imaginary of independent variable, then curve does not exist in that area. Now, sixth point of curve tracing, special point. We check some special point like increasing and decreasing nature of the curve in different region. We use the calculus dy by dx first derivative. If it is 0 in some region, then curve is parallel to x axis. This is the check. Another check, if dy by dx equal to infinity in some region, then curve is parallel to y axis in this region. If dy by dx greater than 0 in some region, then curve is increasing in this region, like this. This is the curve which is increasing because derivative greater than 0. Fourth point of checking in the region, if dy by dx less than 0 in some region, then curve is decreasing in this region. So, this is the curve. Find the point by solving dy by dx equal to 0 and check the values of second derivative at that point. If it is greater than 0, then the point is maxima, and if it is less than 0, then it is maxima, like this. This is the minima and this is the maxima. If d2y by dx square greater than 0 in some region, then curve is concave upward, which is called convex in this region, like this. This is the convex curve or concave upward. If d2y by dx square less than 0 in some region, then curve is concave downward or concave in this region. This is the curve. Check the point of inflection for the curve. If d2y by dx square equal to 0 at some point, then it is the point of inflection. So, this is the point of inflection. Check the point of askew inflection of the curve. If on a point curve has double cusp having horn type first species on the one side of the normal at that point and beak type second species on the another side, then this point is called the point of askew inflection, like this. This is the first type and this is the another type, and one side. So, this is the point of askew. Now, let us illustrate the concept of curve tracing by an example. Trace the curve xy square equal to 4a square 2a minus x. How can we solve this problem? Let us check the symmetry. Curve is symmetrical about x axis because the powers of y are even in the curve. Nature at the origin, the given curve does not satisfy 0 0, therefore it does not pass through the origin. Point of intersection of the curve with axis, putting y equal to 0, we get x equal to 2a, therefore it cuts x axis at 2a 0, shifting origin at 2a 0. To check the nature of the curve, replacing x by x plus 2a and remaining y as it is, we get the equation of the whole whose origin is at 2a0. So, this is the equation whose origin is at 2a0. Tangent at this new origin is determined by putting the lowest degree term equal to 0, that is x equal to 0, because this is the lowest degree term. Converting again it in origin position, we get x minus 2a equal to 0. Now, let us check the asymptote of this curve. Given equation can be written as like this: parallel to x-axis equating the coefficient of highest degree term of x to 0, we get y square plus 4a square equal to 0, that is y equal to plus minus 2ay, 2ai, which is imaginary. Therefore, there is no asymptote parallel to x-axis. Parallel to y-axis equating the coefficient of the highest degree term of y to 0, we get x equal to 0, which is y-axis. Region of existence and non-existence of the curve. For this example, solving the equation, we get like this one: curve exists only for those values of x which lie between 0 and 2a. For other values of x, values of y become imaginary. So, this is the curve. Now, summary: in this lecture, we have discussed the objective of the curve tracing, introduction and definition regarding curve tracing, procedure of curve tracing, example of the curve tracing. These are the references: books, Gorakh Prasad, Differential Equation, Potisala Private Limited, Allahabad, and also these are the books for references. Link to further readings: these are the links to further readings. Student can visit on these links. Now, assessment. Finally, which step is not included in the procedure of tracing of algebraic curve? These are the four options: orthogonality, symmetry, nature at origin, and region or extent. So, correct answer is orthogonality, which is not the step. Now, another question: which of the following curve is symmetrical about x-axis? These are the four curves. So, answer is y square equal to 4ax. Now, let us take another question. True false: at the point where dy by dx equal to 0, the tangent is parallel to x-axis. It is true or false? So, this is the true. So, thank you very much.